In this video, we are looking at the geometric relationships of solids. So let's start with number 1. If you have a cylinder with a height of 8 inches and a radius of 4 inches, and you have a cone with the same height and radius, how many times greater is the volume of the cylinder than the volume of the cone? So we could find the volume of the cylinder and find the volume of the cone using the information provided, but we don't really need to. We can just look at the formula for the volume of each shape. So if we look over here, the volume of the cylinder is pi times r squared times h. If we look at the volume for a cone, it is 1/3 times pi times r squared times h. So they're virtually the same. They have the pi in common, they have the r squared in common, and they have the height in common. The only difference is that you are dividing the cone by 3 or multiplying it by 1/3. So if you multiply both of these by 3, or if you multiply the cone by 3, you would have the same volume as the cylinder. So because of that, the cylinder is 3 times larger than the cone. And that's your answer for number 1. So for number 3, once again, we have a cylinder, but this time we are looking at a cylinder with double the radius. So if the radius is r, a cylinder with double the radius would be 2r. So we can plug that into the equation for volume. Instead of having r squared, we can have 2r squared, and that would be pi times 4r squared times h. So over here we see that the r has turned into a 4r. So we can say that the volume of the cylinder with double the radius is 4 times larger. And that is your answer for number 3. So for number 5, it asks, in a rectangular solid, how many times greater is the volume if you double the length? So in this situation, the width and the height remain the same. The only thing that changes is the length. So usually when you find the volume of a box, it's length times width times height. And over here with the larger box, it's 2L times width times height. So the only difference is the 2, and that means that this is going to be 2 times larger. Okay, let's look at number 7. So over here, it says, in a rectangular solid, how many times greater is the volume if you double the length and the width and the height? So in your first box, you have length times width times height, and in your second box, you have 2L times 2W times 2H. So when you multiply that all out, 2 times 2 times 2 is 8, and then you have length, width, height. So we can cancel out the L, we can cancel out the width, and you can cancel out the height. So we have a ratio of 1 to 8. That means that the second box is 8 times larger than the first one. Okay, in number 9 we have 2 spheres, and it asks, how many times larger is the second sphere if the radius of the first sphere is 1 and the radius of the second sphere is 3? So usually when we find the volume of a sphere, it is 4/3 times pi r cubed. So the formula doesn't change. The 4/3 doesn't change, the pi doesn't change. The only thing that changes is the radius. So we can ignore the 4/3 and the pi and just look at the radius. So 1 cubed is 1, and 3 cubed is 27. So that means that with a ratio of 1 to 27, the bigger sphere is 27 times larger than the first one. And that is your answer for number 9. And that is it for this section.